Assalamu alaikum everyone. Welcome to our presentation. I am Saif Hassan Iman, and today we are going to present the topic Introduction to Assembly Language. Here is our teammates and their IDs. Uh, Before we begin, let's take a quick look at what today's agenda is. In this presentation, we will discuss what assembly language is, why it is important, the basic syntax of assembly instructions, different instruction fields, program data and variables, two commonly used instructions, move and exchange, and finally, some real-world applications of assembly language. Let's begin with a simple question. Have you ever wondered how a computer actually understands the programs we write in languages like C, C++, or Java? The answer is the computers do not understand these programming languages directly. A processor only understands machine language, which is consist of binary numbers, only zeros and ones. However, writing programs entirely in binary is extremely difficult and time consuming. Imagine writing thousands of lines of code using only zeros and ones. It would be almost impossible for humans to read, write, or debug. This is where assembly language comes. Assembly language is a low level programming language that uses short, meaningful words called mnemonic instead of binary numbers. For example, instead of writing a long binary instruction, we'll simply write move ax, bx. It means that the processor have to copy register bx into register ax. It is much easier for programmers to understand than machine code. Although assembly language is easier for humans, the processor still cannot execute it directly. Therefore, a software tool called an assembler converts assembly language into machine language before the program is executed. For this reason, assembly language is widely used in areas like embedded system, microcontrollers, operating systems, robotics, etc. With this basic understanding of assembly language, now let's move on how it actually works. Now I would like to invite my next teammate Faisal Ahmed to explain this. Thank you.
Thank you, Saif. I am Faisal Ahmed. The ID of right. Thank you, Saif. I am Faisal Ahmed. My ID is 2411548. Now let's discuss the basic concepts of assembly language. Assembly language works as a bridge between high-level programming language and machine language. Normally, programmers write code in assembly language instead of binary because binary instructions are difficult to remember. However, the CPU can only understand machine code. So an assembler is used to convert assembly language into machine language before execution. The workflow is very simple. First, we write the assembly program. Then the assembler translates it into machine code. Finally, the processor executes that machine code. Now let's move to the structure of an assembly instruction. Every assembler, every assembly instruction is generally made up of four fields. These are name field, operation field, operand field, comment field. Among this, the operation field is mandatory because it tells the processor which operation to perform. The other fields may or may not be present depending on the instruction. For example, loop 1, move AX BX, copy BX to AX. Here, loop 1 is the name, move is the operation, AX and BX are the operands, and everything after the semicolon is the comment. Understanding these fields helps us write correct assembly programs. Now, I would like to invite Shabab to explain these fields in more detail.
Thank you, Faisal. I am Ibnul Irfan Shabab. My ID is 869. Now let's discuss the instruction field one by one. The first one is the name field. This field is used to give labels or variable names. There are some important rules. A valid name should begin with a letter or underscore, cannot contain space, can contain letter and numbers, and should not start with a digit. For example, start, group 1, and underscore count are valid names. But names like one loop or my worker are invalid. Next, come to the operation field. This contains the instruction that tells the CPU what action to perform. Examples include move, addition, and subtraction. There are also pseudo operations such as db, dw, and proc. These are not executed by the processor. Instead, they help the assembler organize the program. Now let's discuss the operand field. Operand specific the data involved in an instruction. Some instructions have no operand. For example, not some have on operand INCAX and some have two operand add x bx. Finally, we have the comment field. Comments begin with a semicolon. They are ignored by the assembler but help programs understand the code. For example, add AX, BX, add BX into AX. Comments improve readability and make debugging much easier. Now I would like to invite Raful to explain program data and the MOV instruction.
Thank you, Shabab. My name is MD Rafiul Karim. My registration number is 241154442. Now let's discuss program data. Inside the computer, all information is stored in binary form. However, in assembly language, programmers can write numbers in different forms. These include binary, decimal, hexadecimal. Characters are stored using ASCII code. For example, the character A is stored as hexadecimal 41.8. Assembly also allows programmers to define variables. Directives are DB for define byte, DW for define word, DD for define double word. These directives reserve memory for storing data. Now let's discuss one of the most commonly used instructions, the move instruction. The purpose of move is transfer data. Its syntax is very simple. Move destination source, for example, move AX and BX. Um, Copies the contents of register BX into register AX. Similarly, move AL, comma A stores the ASCII value of character A inside register AL. It is important to remember the mob copies data but does not delete the original value from the source register. Now I invite our final presenter Asha to explain the AXAC conclude the presentation. Thank you.
Assalamualaikum everyone. I'm Sadia Finasha. Now I will discuss about the exchange of instructions. Sometimes we need to exchange the values of two registers. Without XCHG, we need three move instructions and one temporary register. For example, move AX into CX, move BX into AX, move CX into BX. This takes multiple instructions. Instead, assembly provides a much similar instructions. XCHG, AX, BX. This single instruction swaps the values of AX and BX directly. It saves both time and code space, making programs more efficient. Now let's look at some real-world application of assembly language. Assembly language is widely used in embedded systems, device, drivers, robotics, Internet of Things or IoT, operating systems, reverse engineering, etc. These applications requires direct hardware control and high performance, which assembly language provides. Finally, let's summarize today's presentation. Today we learned that assembly language is the programming language closest to machine language. It gives programmers direct access to CPU registers and memory. We also discussed instruction syntax, data representation, variables, and important instructions such as move and XCHG. Although assembly language is more difficult than high-level languages, it remains essential in embedded systems and hardware programming because of its speed and efficiency. Thank you everyone for your attention. We hope you found our presentation informative.